Metals, nonmetals, and metalloids. General properties of metals. Metals have low ionization energies, luster, ductility, low electronegativities, and they are malleable. Although this unit focuses primarily on periodic trends, there are some important things to know about how certain groups of elements behave in chemical reactions. Most metal hydrides, oxides, and nitrides are basic when combined with water. So here we have an example of calcium hydride reacting with water to produce aqueous calcium ions, hydroxide ions, and hydrogen gas. In the above formula, calcium hydroxide is shown as ions as calcium hydroxide is a strong base. Hydrogen gas is also released in this process. Let's look at strontium nitrate reacting with water to form strontium ions, hydroxide ions, and ammonia. In the above reaction, strontium hydroxide is shown as ions as strontium hydroxide is a strong base. The nitrogen in the strontium nitride also combines with water to form ammonia, which is a weak base and therefore is not shown as ions. Most nonmetal oxides are acidic. They react with water to produce acids. So here we have sulfur dioxide reacting with water to form sulfurous acid. Sulfurous acid is a weak acid and is shown here in its molecular form. Sulfur trioxide reacting with water will form hydrogen ions and hydrogen sulfate. The formation of sulfuric acid is shown in an ionic form where the first hydrogen is the only ionized ion. Carbon dioxide reacting with water will form carbonic acid. Carbonic acid is a weak acid and is shown here in its molecular form. Dichlorine, heptoxide, and water will form hydrogen ions and perchlorate ions. Perchloric acid is a strong acid and fully ionizes. Diphosphorus pentoxide plus water will give you phosphoric acid. Phosphoric acid is a weak acid and is shown here in its molecular form. Dichlorine trioxide and water will form chloric acid. Chloric acid is a weak acid and again is shown here in its molecular form. Group trends of active metals. You should have a basic understanding of the properties of alkaline metals. All alkaline metals react with water to produce hydrogen gas. They will all form hydrides, and all alkaline metals react with most nonmetals. Sodium, potassium, rubidium, and cesium will form peroxides. An example of this is sodium metal reacting with oxygen to form sodium peroxide. Potassium, rubidium, and cesium will form superoxides. So this example shows potassium reacting with oxygen to form potassium superoxide. Each alkaline metal emits a characteristic color. So for an example, lithium is more of a crimson red, sodium is yellow, and potassium is violet. You should also have a basic understanding of the properties of the alkaline earth metals. Calcium and metals below it will react with water. Magnesium does not react with water, but will react with steam. Magnesium and calcium will both form oxides, barium will form a peroxide, and all will react with nonmetals. Each alkaline metal will also emit a characteristic color. So for example, calcium will be a brick red, strontium will be a crimson red, and barium will be a greenish yellow. Properties of nonmetals that you should be familiar with. They are brittle, they have high ionization energies, they lack luster, have high electronegativities, and most are in the solid or gas phase, with the exception being bromine, which is a liquid. Group trends for selected nonmetals. You need to know the definition of an allotrope. An allotrope are different forms of the same element in the same state. So some examples of allotropes. Carbon can be an allotrope. It can exist as either graphite or a diamond in the solid phase. Phosphorus can also be an allotrope. It has two forms, a white form and a red form. Oxygen has allotropes. It can either be molecular oxygen of O2 or ozone, which is O3. And finally, sulfur can exist as different allotropes, as either sulfur as a solid or sulfur 8. Finally, an important thing to remember is that the halogens exist as diatomic molecules. The halogens also exist in different states. Bromine is a liquid, Fluorine and chlorine are both gases, and iodine is a solid, but it will sublime at room temperature, as it can go from a solid to a gas.